In this video, we'll try and understand the saving investment model in a closed economy setup. And so we are going to use a spreadsheet to numerically as well as graphically understand the basic setup of the model, the equilibrium, and how is it affected by the shocks that can happen to different exogenous variables. So here we have a set of exogenous variables: output, the autonomous part of consumption, the marginal propensity to consume, and then the autonomous part of investments, or the investment function intercept, the slope of investment function, and the government spending and taxes minus the transfers. So these are our exogenous variables, and these are the initial values of these exogenous variables. Now you may want to refer to my other video where I exactly use the same numbers as well as use these analytical symbols to try and derive and solve for the endogenous variables, both analytically using analytical framework as well as using numerical framework. So here our focus is going to be how we can use a spreadsheet to see how different shocks that can happen to exogenous variables is going to affect our equilibrium. Now, given these exogenous variables, we can always derive the budget balance, which is the taxes minus the government spending. So 2,500 minus 3,000, that's 500 negative. So that's a budget deficit. Then when you plug in the value of y into the consumption function, we get consumption equals to 12,700. And the savings, which is y minus c minus g, is just going to be 18,000 minus 12,700 minus 3,000, that gives us 2,300. And so when you solve for r, you get 3%, or 3. Again, you may refer to my other video where I actually derive this number 3. Here the focus is not on derivation of number 3, but it's more on how we can use a spreadsheet to make sense of the dynamics of the model. And notice obviously the investments is going to be equal to the savings. So once you plug in this 3 in the investment function, 3,500 minus 400 into 3, that's 3,500 minus 1,200, you get 2,300, right? And so these are the shock values to different parts of the model. So you can have a consumption shock, we can think about an investment shock, we can think about a government spending shock. This is a policy variable, so a policy shock coming from the government, and then similarly the shock coming from the government through taxes. And of course we can also think about the shock to the total output that is coming from labor and capital, right? So these are the potential avenues where the shock can come from, and we would like to see how it's going to affect our equilibrium in a very precise way using exact numbers. So here's the graphical representation of these values, whereby our savings, which is equal to y minus c minus g, is 2,300. Notice it is 2,300. And then investments, a function is negatively sloped, and that is given by this investment function. So it's in equilibrium, the savings and investments is 2,300 and the interest rate is 3. So on vertical axis we are measuring the interest rate, so that's 3%, and on the horizontal axis we are measuring billions of dollars. So in this case it would be 2.5 or 2.3 trillion dollars, which is savings and investments. Now let's shock the system. Let's assume that there is a downturn in business condition and there is a drop in investment spending by 500 or 500 billion dollars. As a result, you can clearly see that the investment function is going to shift left, and causing the interest rate to go down to precisely 1.75%. Right? We can also think about a shock to consumption. Keep in mind, consumption is in the savings function, so it's in this vertical line, right? So let's say we shock the consumption by a positive 200, right? So it goes up 200. Because the consumers are spending more, as an economy, we would save less. So obviously you can clearly see that the solid red line, which is given by the initial values, has now shifted to this dotted line, which is the new value after the shock of positive $200 to the consumption. So the new consumption level is autonomous part has gone up to 500, and as a result the interest rate has gone up to 3.5%. So there you can clearly see that the real interest rate has gone up to 3.5%, and the investment as well as the savings has gone down, right? The good part of this spreadsheet is, or the setup that we have over here, is that we are no longer limited to just shocking the system one part. So we don't have to shock just to consumption. We can think about a shock to the investments and the consumption and the output and the government spending and the taxes all at the same time, because that's what typically happens, right? In a real world scenario, there is a drop off, there is a shock to investments, a negative shock to investments of $500 billion, and the government is somehow going to respond to this shock, right? That's typically what the policymakers are geared towards, which is when there is a shock to the economy, the policymakers is then going to take some action to mitigate those shocks, right? So in this case, let's assume that there is a negative shock of $500 billion to investments, and the government steps in and spends $300 billion more, right? So as a result, you can see that now because of investment shock, the investment function has shifted left, but at the same time, the government is also spending more, right? If the government is spending more, as a whole, the savings in the economy will go down, right? So whether the consumers spend more or the government spends more, at the end of the day, the national savings is going to go down, which is represented by the left shift of the savings function. You can see that the new equilibrium point is then going to be 2.5 in terms of the numbers. Also, you can see it over here, and the equilibrium savings and investment is going to be 2000, right? Now let's say there is a positive shock of $1 trillion to output, either through technology or capital labor. You would expect the savings to go up, right? Because Y is going up. But notice here the government spending is still 300, and because Y has gone up, the consumption is going to go up as well by a factor of 0.8. So out of this $1 trillion, there is an increase of 0.8 of that $1 trillion, $800 billion increase in consumption, and there is already an increasing government spending of 300, right? So 300 plus 800 is 1100, and though income has gone up by $1 trillion, the spending 300 plus 800 in consumption has gone up by 1100. As a result, the total saving investment balance has gone down by 100, and therefore the interest rate has gone up to 3.25. You can just keep on playing with this different kind of scenario where you can open up a newspaper and see how the consumers are behaving. Put the value of the shock over here, negative 100. Maybe the investment climate is a positive, and that goes up 300, and the government is trying to recover this money through tax collection, that is spending more. Remember, it is having a deficit of 500, trying to cover up this deficit by imposing an additional tax of $500 billion. Then what will happen to the economy? So here's a classic example where the shocks are happening to different parts of the economy at the same time, as well as the government is reacting to this shock or government is also trying to do its own business. And we can parallelly see if all of these things happen together, what is the impact on the equilibrium interest rate. Over here, the interest rate has gone down from 3% to 2.75%, and the savings and investment equilibrium has gone up from 2,300 to 2,700. You can see that over here, this is 3%, whereas this is 2.75% interest rate, the new level.